Bismillah Rahman Rahim. Today I am again with you with some more problems of the higher order differential equation. Here in the next problem we have a polynomial we have a third degree polynomial in the differential equation. So this is a second order differential equation. For solution of the differential equation, first we will find the complementary function, and you know that we have already solved many problem before, so you know that how to find the complement solution of the complementary function at the left hand side. So I am directly writing here complementary function of the differential equation, that is yc is equal to c1 exponential x plus c2 exponential 3x. Now I will show you how to calculate the particular integral. So from equation number 1, we will equate the value of y, that is x cube upon d square minus 4d plus 3. So it can be written as d square minus 4d plus 3 whole raised to the power minus 1 x cube, because this is the case of the polynomial. So in case of polynomial, we must be shift the denominator into the numerator to transform into the power function. Now this power function will be transformed into the binomial function by taking common 3 from the entire term. So when we will take the common 3 from here, so it can be written as 3 times 1 minus 4 upon 3d plus 1 upon 3d square into x cube. So these terms into the bracket will be transformed into the formula. So we will break the terms into the two terms. First term will be a, and the rest of term will be the second term. So now we have two terms, 1 minus x raised to the power minus 1. We will apply the simple binomial expansion, that is 1 minus x raised to the power minus 1 can be written as 1 plus x square plus x cube and so on. So we can apply this formula on our problem, that will be 1 upon 3 this uh, because 3 raised to the power minus 1, from here 3 raised to the power minus 1, that will be 1 upon 3. So we can write 1 upon 3 outside and apply the formula on the entire term, that will be 1 plus x square plus x cube and so on. Outside the bracket is we have our polynomial, that is x cube. So here uh, first term will be 1, and the second bracket 4 upon d 4d upon 3 minus d square upon 3 plus second term, that is 4d upon 3 minus d square upon 3 whole square. So we will apply here a minus b whole square formula, so that it can be written as 16 d square upon 9 minus d4 upon 9 minus 2ab, that is 8d cube upon 9 plus, and third term is 4d upon 3 minus d square upon 3 whole cube. So this third term, which will be expand by using the formula of a minus b whole cube. So according to the a minus b whole cube formula, that will be a cube minus b cube minus 3a square b uh, minus 3ab square plus b cube. So according to that one, and uh, and so on, multiply by x cube. The, now after we will simplify and add subtract those terms which are similar in power of d. So 1 1 upon 3 1 plus 4 upon d, and d square upon 3 16 d square upon 9, this will be combined, so 13 upon 9 d square plus also we have minus 8 upon 9 d cube 64 upon 27 d cube becomes 40 upon 27 d cube, and we are terminating the rest of terms containing the higher power of d, because we have our polynomial of degree 3, therefore, and you know that When you will differentiate x cube up to 4 times, this will be 0. Therefore, we will only takes the order of differential 3, maximum terms containing the order 3. So 1 upon 3 plus 1 plus 4 upon 3d plus 13 upon 9 d square plus 40 upon 27 d cube into x cube, right? So multiply x cube with all the terms, so that 1 upon 3 x cube plus 12 upon 3 differential of 4 upon 3 differential of x cube plus 13 upon 9 d2 of x cube plus 40 upon 27 d3 of x cube. Now 1 upon 3 x cube plus 12 upon 3 differential of x cube, that will be 3x square. 3x square multiplied by 4, that will be 12 upon 3x square. Now differential of x cube, that will be 3. So we will differentiate it 2 times, that will be 6. Second order derivative of x cube. Here I show you the derivative of the different orders. And differential of x cube will be 3x square. Second order derivative of x cube will be 6x, and third order derivative will be 6. So by substituting their values and multiplying by the equation, we get 1 upon 3 x cube plus 4x square plus 26 upon 3x plus 80 upon 9. Now we will write the whole solution of the differential equation, that is y is equal to yc plus yp. So it can be written as c1 plus c1 exponential x plus c2 exponential 3x plus 1 upon 3 x cube plus 4 upon 3 x square plus 26 upon 3x plus 80 upon 9. This is our final answer. Now we are going to solve or discuss another problem containing circular function, that is d square plus 9y times is equal to cos 3x. For the complementary function from the left hand side, here we have d square plus 9 is equal to 0, and the roots of this differential equation will be this m square plus 9 will be m is equal to plus minus 3 iota. Here we have complex root. In case of complex root, you know that the solution can be written as c1 cos bx plus iota c2 sin bx exponential power ax. So yc is equal to c1 cos 3x plus c2 sin 3x exponential a. Because a is 0 here, so we will write here exponential 0x. So exponential power 0, that will be equal to 1. So this entire factor will be vanished from here because the value of factor is 1. So 1 will multiply the whole term, that will be yc is equal to c1 cos 3x plus c2 sin 3x. Now for the particular integral, pi is equal to, from equation number 1, pi is equal to y is equal to cos 3x upon d square plus 9. So according to the formula, when we have 1 upon f of d square cos bx, it can be written as cos bx upon f of minus b square. Here b is equal to what? 3. So when we will substitute 3 here, that will be what? Uh, that will be minus 9 plus 9 will be 0. So therefore we cannot apply this formula directly. What we have to do, we must be differentiate before. So now look at this. When I substitute b here, what happened? Minus 9 plus 9. So that will be 0. Formula false. Therefore what you have to do? We'll apply this formula. 1 upon f of d square cos b is equal to x times minus cos b upon f prime minus b square. So uh, yp will be equal to what? X dot x multiply cos 3x upon 2d And for instance d, we will substitute what? For instance d, we cannot substitute because must sub- we must need the uh, value of d square to replace the value of b. So, and we know that another alternative is 1 upon d can also be written as the integral. 1 upon d is the integral, so that this can be written as integral of cos 3x d. And you know that how to find the integral. The integral of cos, you know that the integral of cos is can until you cannot find the integral of the trigonometric function until you don't have the differential of the angle. So angle is 3x, so we must need 3 to integrate this entire term. So when 3 is not present here, so we can directly integrate and divide by the 3. So this will be the complete integral of the cos 3x. So x upon 2 minus sine 3x upon 3 is the integral. So multiply these two terms so that we get x upon 6 sine 3x. This is our particular integral. Now the general solution of the entire differential equation becomes y is equal to yc plus yp, that is c1 cos 3x plus c2 sine 3x plus x upon 6 sine 3x. Here I am trying to solve the different kind of problems to gives you the more clear overview regarding how to proceed the solution in case of the different type of uh, functions in the higher order differential equation. So now I choose another problem of higher order differential equation. Here we have third order differential equation with two functions which are exponential and trigonometric. So in this equation, have a look. D3 minus 3d square plus 4d minus 2 times of y is equal to exponential x plus sin x. So from the left hand side, as usual, we will find the complementary function. So it is the third degree equation. First, we will write the uh, auxiliary equation of the entire differential equation of the right hand side, and by using the centric division method we obtain the first root and the rest of two root by using the quadratic formula. So here we have three roots. First root is m1 is equal to 1, and rest of two roots are the complex roots, which is rest of two roots are the complex roots which are uh, 1 plus minus iota. First root is m1 is equal to 1. So here we can write the complementary function yc is equal to c1 exponential x plus c2 cos x plus c3 sin x exponential x. So according to the rule here, we will write c2 cos bx plus c3 sin bx exponential ax. So here value of a and b both is 1. So that will be c2 cos x plus c3 sin x exponential x. Now from equation number 1, particular integral becomes y is equal to exponential x plus sin x upon d3 minus 3d square plus 4d minus 2, and breaking the LCM, it can be written as exponential x upon d3 minus 3d square plus 4d minus 2 plus sin x upon d3 minus 3d square plus 4d minus 2. So again we will apply two different formulae here. So first formula, a exponential bx upon f of d can be written as a exponential bx upon f of b in case when f of b not equal to 0. So directly here the value of b is 1. So when you will apply here this formula, so you cannot get the solution here because we know that the before earlier we know the one is the root of the differential equation, so we cannot directly substitute one here. We must be differentiate the denominator to find the solution of the first part. So what is the rule? According to the rule, it when we have a exponential bx upon f of d, is it can be written as x times in case of when we have f of b, when f of b is equal to 0. In case we must apply this rule. So a exponential bx upon f of d can be written as x times a exponential bx upon f prime b. Now x into exponential x divided by derivative of term, which term, this term, d3 minus 3d square plus 4d minus 2 will be 3d square minus 6d plus 4. So 3d square minus 6d plus 4, right? And the second term, it can be written as sine x divided by d3 can be break as d into d square minus 3d square plus 4d minus 2. Why we are breaking this terms in d cube into d square? Because we apply here rule, according to that we must be replace minus b square instead of d square. Therefore we breaking this d cube into the d into d square. So now first term x times of exponential x, and the value of b here is coefficient of x into the power of exponent, that is 1. So 3 1 square minus 6 into 1 plus 4 plus sine of minus b square, and coefficient of x in the angle of sine, that is 1. So here for instance d square will substitute minus b square. This negative sign is separate, and the square is only on the 1. So that will be minus 1 square, similarly minus 3 minus 1 square plus 4d minus 2. Now x times exponential x upon 3 minus 6 plus 4. So uh, this will be written as x into exponential x divided by 3 minus 6 plus 4 plus sin x upon minus d plus 3 plus 4d minus 2 divided by oh, uh, minus 2, and x exponential x upon 1 plus sin x divided by 3d plus 1. Now here we will multiply and divide by 3 minus 1 at the right hand term, because the left hand side is the solution. We will not do anything with this one, so it will remain same. But the second term here, we need to uh, obtain the value of d square, so that we will multiply and divide by the conjugate. So in the denominator we will have 3d square minus 1 into 3d minus 1 3d plus 1. uh, that will be according to the difference of 2 square, a square minus b square, and the numerator will remain 3d minus 1 into sin x. So x into exponential x plus 3 d square minus 1 sin x upon 9 d square. For instance, according to the formula, for instance, d square we will substitute minus 1 square minus 9, so that will be minus 9 minus 1, that is minus 10. So x exponential x minus 1 upon 10 3 3d minus 1 into sin x. So further, so x exponential x minus 1 upon 10 3 differential of sin x plus 1 upon 10 sin x. So x into exponential x minus 3 upon 10 derivative of sine, that will be cos plus 1 upon 10 into sin x, 1 upon 10 taking common from here, so that we can write it as x into exponential x minus 1 upon 10 3 cos x plus sin x. This is our particular integral. Now we will write the entire solution, that is y is equal to yc plus yp, that is complementary function plus particular integral. So y is equal to c1 exponential x plus c2 cos x plus c3 sin x into exponential x plus x times exponential x minus 1 upon 10 times of 3 cos x plus sin x. So this is our uh, full solution of this differential equation. Now in another case, this is the special case of the differential equation. Here when we have two terms in form of multiplication, so here we will use some basic formulae of the trigonometric. We will apply here, which are uh, we already studied in intermediate classes. So now look at this, how to find the solution of this particular problem. So here, see, see at the left hand side we have d2 plus 1 into y is equal to sine 3x cos 2x. So first we will find the complementary function. The auxiliary equation at the left hand side will be m square plus 1. So from here we will get the root m is equal to plus minus iota. These are the complex roots. In case of complex root, our solution will be c1 cos bx plus c2 sin bx exponential ax. So a is 0, b is 1, so that yc is equal to c1 cos x plus c2 sin x into exponential 0, and exponential 0 value of this will be 1. So this will be replaced by the 1. So yc is equal to c1 cos x plus c2 sin x. Now for the particular integral, we will equate the value of y from equation number 1, that is y is equal to sine 3x cos 2x divided by d square plus 1. So there is no rule we have to solve such a kind of problem, so that here we will transform this term cos 3x cos sine 3x cos 2x in term of addition or subtraction. So according to the formula, basic formula of the trigonometric function, that is what, cos alpha sin alpha cos beta, because sin alpha cos beta is equal to what, sin alpha plus b cos sin alpha plus b plus sin alpha minus b whole divided by 2. So for instance, we can write it as y is equal to 1 upon 2 sin 3x plus 2x, because alpha is 3x, beta is 2x. So sin 3x plus 2x plus sin 3x minus 2x whole divided by d square plus 1, and further 1 upon 2 sin 5x plus sin x upon d square plus 1. Now we have transformed our function from uh, multiplicative product form to the addition form. Now we will break the LCM. So by breaking LCM, this term can be written as 1 upon 2 into sine 5x upon d square plus 1 plus 1 upon 2 sine x upon d square plus 1. Uh, According to the formula, because sine bx upon f of d square can be written as sine bx upon f of minus b square, according to the rule, when f of minus b square provided not equal to 0. Otherwise, we will differentiate the denominator and uh, proceed toward the solution as we have discussed previously. So we will write here 1 upon 2 times sine 5x upon minus b square if the value of b is 5, plus 1 plus 1 upon 2 x times minus y. We are differentiating this one because here the value of b is 1. So when you will substitute here minus 1, that will be minus 1 plus 1 0. Due to this, we must be differentiate the denominator here in second term. So it will be 1 upon 2 um, into x times sine x upon f prime d, that is 2d plus 0. Now here we will substitute the value of b in the next step. So 1 upon 2 into sine 5x upon minus 25 plus 1 plus x upon 2 sine x upon 2d. 2d. So 1 upon 2 sine 5x upon minus 24 plus x upon 2. Uh, we can find the solution of this term by uh, uh, taking 2 here, and this will be x upon 2, and 1 upon t will by integrating. So directly sin x, we can also uh, find the solution of this factor. So but here, because I am doing the same way, all the problem solving by using the same way. So therefore, I multiplying and divide by d here to get to apply the same formula. So after multiply and divide by d, this becomes d sine d upon 2d square. For instance, d square I will substitute minus 1 square in the denominator. You can look at this minus sine 5x upon 48 plus x upon 4 d times of sine x upon minus 1 square. That will be plus minus minus, and derivative of sine is cos. uh, Another an alternative I will explain you here. If you like to do it, this portion, x upon 2 into 2 here, that will be x upon 4, right? And sine x upon d can be written as integral of sine. So what is the integral of sine? Integral of sine is cos. You know that, minus cos. Integral of sine is minus cos. So x upon 4 into minus cos, right? So that in this case you will get the similar solution, that is x upon 4 into cos x. So now the final solution of the differential equation will be y is equal to c1 cos x plus c2 sin x minus 5 sin 5x upon 48 minus x cos x upon 4. Now another problem. In this problem we have uh, trigonometric function, but this time we we have chosen another type of trigonometric function. This function is a power. So in case of power function, when we have this type of problem, when we have power in the trigonometric functions, so how we can find the solution of the differential equation, especially in case of particular integral. And you know that how to deal with the differential equation for a complementary function, and therefore I am writing here directly solution of the complementary part, that is d square plus 1 will be m square plus 1. So the complementary function yc is equal to c1 cos x plus c2 sin x. Now for particular integral, this equation can be written as y is equal to cos square divided by d square plus 1. One very popular trigonometric identity we have already studied in the intermediate classes, that is cos 2 theta is equal to 2 cos squared theta minus 1. By using this identity, we extract the value of cos squared theta from here, that is cos square x from here. That will be by shifting 1 to left hand side and divide the entire term by 2. So that we will substitute here cos 2x plus 1 whole divided by 2 divided by d square plus 1. This divide this will multiply to the denominator, so it can be written as 1 upon 2 cos 2x plus 1 divided by d square plus 1. Now our problem from the power function is transformed into the linear function. Now by breaking LCM, this can be written as 1 upon 2 multiplied by cos 2x divided by d square plus 1 plus 1 times exponential 0x, because there is uh, uh, absence of the exponential function, and you know that e power 0x is equal to 1. Therefore, for instance, we can write here exponential 0x to apply the formula directly on that upon d square plus 1. Here we know that cos bx upon this formula, we know that cos bx upon f of d square is equal to cos bx upon f of minus b square, and a exponential bx upon f of d is equal to a exponential bx upon f of b. So by using these formulae, our solution becomes 1 upon 2 cos 2x upon minus 2 square plus 1 plus 1 times exponential 0x upon 0 square plus 1. So cos 2x minus 4 plus 1 plus 1 upon 1, 1 upon 1 upon 2 cos 2x upon minus 3 plus 1. So it can be written as minus cos 2x upon 6 plus 1 upon 2. So the general solution of the entire differential equation will be y is equal to c1 cos x plus c2 sin x plus 1 upon 2 minus cos 2x upon 6. So this is the solution of differential equation. Now another problem is, look at this problem number 10. This problem is also containing the two functions at the right hand side which are in form of product, but this time we have algebraic function with exponential function. So you know that how to find the solution of the left hand side, or how to proceed for the complementary function. So from the left hand side, the auxiliary equation m square minus 4m plus 4 is equal to 0, and we have two roots. Both the roots are repeated roots, so the complementary function becomes yc is equal to c1 in plus c2x exponential 2x. Now for the particular integral from equation number 1, y becomes x square minus exponential 2x divided by d square minus 4d plus 2, and here uh, we will apply this formula. uh, this formula for what is formula? This formula, when we have mm, a exponential bx into another function g whole divided by f of d, can be written as a times exponential bx into 1 upon f of d plus b into g. So what we have to do here, uh, for instance g, we will replace d plus b instead of d in the entire term, in the entire function. So now in the problem we can write it this, y is equal to x square minus exponential 2x divided by d square minus 4d plus 4, as coefficient of exponential 2x is 1, so exponential 2x into 1 upon d plus b. So what is b is 2 here, so it can be written as d plus 2 whole square minus 4 times of d plus 2 plus 4 into g of x. G of x is x square. So exponential 2x 1 upon d square plus 4d plus 4 minus 4d minus 8 plus 4 to x square. So minus 4d plus 4d cancel out, minus 8 will be cancelled out, plus 4, right? So the remaining term is exponential 2x into 1 upon d square and 1 upon d square into x square. It means that you have to integrate this x square two times. So let's see what happened now. So we will integrate x square two times, and you know that how to find the integral. So there is no any complicated issue to find the integral of simple x or x square. So here d square can be written as 1 upon d, 1 upon d of x square. So exponential 2x into 1 upon d, and the integral of x square will be x cube upon 3 plus integration constant c. Also uh, exponential 2x, exponential 2x, now we will integrate this entire factor which is into the bracket. uh, Integral of x cube will be x4 divided by 4. This 4 will be multiplied by 3. So it can be directly written as x4 upon 12 plus integral of c3 will be c3x. So this is our, because we can include here another constant c4, no matter uh, if you want to write there, because this is the constant. So this is the indefinite integral, and when we have, in case of indefinite integral, we use integration constant to balance the equation. So uh, in the entire solution, in the end, I can also add some uh, some constant term here, something like that. This constant represent the all constant values. So the general solution of the differential equation will be y is equal to c1 plus c2x exponential 2x plus c3x plus x power 4 divided by 12 times exponential 2x plus c, right? Now in the next problem, we are trying to solve another problem in product form. So look at the differential equation we choose, that is d3 minus 7d square plus 10d times y is equal to exponential 2x into sine x. So you know that uh, how to find the complementary function. So the auxiliary equation of the given equation will be m cube minus 7m square plus 10m is equal to 0. By taking common m from the entire terms, that will be m times of m square minus 7m plus 10 is equal to 0, so that we will get the three roots here from m is from this equation m is equal to 0, or from this quadratic equation m is equal to 2 and m is equal to 5. Now the complementary function can be written as yc is equal to c1 exponential m1x plus c2 exponential 2x plus c3 exponential 3x m3x. So that will be yc is equal to c1 plus c2 exponential 2x plus c3 exponential 5x. Now the particular integral can be written as y is equal to exponential 2x into sine x divided by d3 minus 7d square plus 10d. Uh, we will apply the same formula as I I told you earlier. A exponential bx g of x divided by f of d can be written as a exponential bx into g of x upon f of d plus b. So yp is equal to exponential 2x 1 upon d plus 2. B is 2 here, the power of exponent, that is 2. So 1 upon d plus 2 cube minus 7 times of d plus 2 square plus 10 times of d plus 2 into sine x. Now d plus 2 can be expanded by a plus b whole cube, and d plus 2 whole square expanded by a plus b whole square, that would be d cube minus 6d square plus 12d plus 8 minus 7d square minus 28d minus 28 plus 10d plus 20. uh, Here sin x must be, I forget to write sin x, and the remaining term exponential 2x minus 1 upon d cube 6d 7d minus d square 6d square minus 7d square, and 12d minus 28d and 10d. The remaining term is minus 6d, 8 plus 8, uh, 20 and 12. 8 plus 8, 28 and 20 will be cancelled out. So we have only this term. Now this d cube can be written as d square into d minus d square minus 6d, because we will substitute here minus b square, for instance d, according to the formula sin bx upon f of d square is equal to sin bx upon f of b square minus b square. So exponential 2x minus 1 upon minus 1 square into d minus minus 1 square minus 6d uh, sin x. So this will be exponential 2x minus 1 upon minus d plus 1 minus 6d into sin x, and exponential 2x minus 1 upon 1 minus 7d into sin. Now multiply and divide by 1 plus 1 plus 7d, so that we will obtain difference of 2 square in the denominator, that is uh, 1 plus 7d times of sin x divided by 1 minus 7d, 1 plus 7d, provided difference of 2 square in the denominator, that will be a square minus b square, that is 1 minus 49 d square. Now apply the formula in the denominator, that will be minus 1 square, for instance d square minus b square in the denominator. So the factor in the denominator will be equal to what? The denominator term can be written as 1 plus 7d divided by 1 minus 49 minus 1 square into sin x, and that is minus minus plus 49 plus 150. So this will be the coefficient. It will be written in the beginning of the solution, that is 1 minus 50 exponential 2x, and the rest of term is 1 plus 7d into sin x. Now sin x will multiply by 1 plus 7d, can be written as 1 upon 50 exponential 2x sin x plus 7 d sin x. Differential of sine is cos, sorry, differential of sine, yes, differential of sine is cos. So this will be 7 cos. Now yp becomes 1 upon 50 exponential 2x sin x plus 7 cos x. So the final answer of the differential equation will be y is equal to yc plus yp, that is complementary function, and particular integral c1 plus c2 exponential 2x plus c3 exponential 5x plus 1 upon 50 times exponential 2x into sin x plus 7 cos x.